Great session. This is the final session for today. Wendy Martinez will be chairing it on data editing and imputation, and I believe we originally had 4 speakers. One unfortunately was unable to be here today, so I will turn it over to you, Wendy. Take it away.
All right, thank you. It's always tough being either the one right before lunch, right after lunch, or right when it's ready to go home or be done for the day. Okay, great. Well, I think all of our speakers are here. And as you know, all attendees put your questions in the Q&A. That's the best place for them. And we will ask the speakers at the end. Now, this is a regular paper session, so the speakers have 15 minutes around there for their talk. And I'll jump on if and let you know your time's up if things are going too long. But anyway, looking forward to the 3 talks that we have. And first up, we have David Tusi. Go ahead and share your screen and start your talk.
Hi, Dr. Martinez, can you hear me?
Yes, I can hear you. And feel free to call me Wendy.
Okay, let me see. How do I share my screen here?
Yeah, there should be a green button at the bottom.
Oh, there is. There is. I see it. I see it right here. Here we go.
Yeah. And then the other
Uh,
weird thing is once you select what you want to share, you actually have to hit the share button. I always forget to do that I have to do that.
that's interesting.
Yeah. So
Okay.
it's sort of like a two-step
Yeah, I see that.
two-step process, maybe 3
Okay,
steps. All right,
thanks.
thanks.
Let me put my email here in the chat box. Um, so hi, good afternoon. My name is David Tussey. I'm a former executive director at the New York City Department of Information Technology. This presentation is a look at the 311 data from New York City and an attempt to sort of understand, is it getting better? What's the level of quality? And we'll talk here briefly through a framework for measuring data quality over time. One caveat, I'm coming to you from South Florida. We've had a power failure, so I'm completely on batteries. I hope that will hold out through the presentation. Um, um, my colleague in this presentation was Dr. Jun Yan. He's a professor of statistics at UConn. And so let's just jump right into it. So let's see here. Okay. Um, New York City enacted their open data law in 2012, huge initiative. All the agencies had to comply, and all their data, performance data, was put into a large central data lake. Currently, the data has about 2,700 data sets with all kinds of city agency performances. The most viewed data set that New York City has are the 311 service requests. 311 is a number that was set up, and as many cities use this for non-emergency issues, 911 for fire and police, and 311 for everything else. And everything else is a lot. It's not just a phone line, it's also available online, a mobile app, and it is a really rich, robust, easily accessible data set, and it's a great one to jump into. And it's got all the problems you might imagine that an open data set has to provide. And this presentation takes a look at that. Before I actually get started with this particular presentation, a little background here and a kind of a little funny story on what sort of led me down this path. I used to work as a product manager on Google Maps a long time ago. Google Maps actually uses dozens of curated data feeds for their business listings. And I'm specifically talking here about looking for a business like sushi restaurant or Home Depot or Starbucks. Um, Not the other map functions like driving directions or something like that. However, there's one main data feed that comes in every month from an external vendor that we used to use. When that feed arrives, there's a cron file that kicks off the MAPS database is automatically rebuilt overnight. So sure enough, 1 month that feed arrived, the database was automatically rebuilt. And we were in New York, but we come to work in New York the next day, and every Canadian business on Google Maps was listed with exactly the same phone number. So, and turned out to be a phone number for a Walmart in the Toronto area. There's about 1 million Canadian businesses. Every single one had the same phone number. And we were able to quickly determine that the problem was really in the data feed. So the question is, how do you prevent that from happening again? So what we went through is we identified a series of quality metrics for each of the data feeds. For example, duplicate phone numbers, invalid zip codes, duplicate business addresses. Some of the other presenters have indicated some of the challenges with things like multiple businesses with the same addresses or residents with the same addresses. Same thing in the business world. And then we implemented QA approaches that were found traditionally in manufacturing and specifically statistical process control. And so we would take these data feeds and create a control and a P chart. And then, of course, we developed some software to detect those anomalies. And if they exceeded more than 3 sigma, we flagged it and we didn't use that. And of course, if we'd been doing that before, we would have detected that this one feed had a huge spike in duplicate phone numbers, and we would have trapped it and not had that fire drill that we had to do to go correct that. And we took a similar approach in this case for using the 311 data. We identified 8 quality metrics. We tracked those over 15 years. It's a big data set, almost 40 million rows. And then we looked at, for these quality metrics, at the percent of non-conforming anomalies. And to determine the change, we looked at the mean of the first year, 2010, the mean of the last year, 2025, and that delta gave us the percent change over time. And we're trying to answer this question of, is the data getting better? And this approach gives us some insight to do that. These are the 8 metrics. I'm not going to go through each of these, but I am going to focus on the top 3 for demonstration purposes. But you can kind of see the idea of what we're looking for in the data feeds. Invalid zip codes, invalid community boards, service requests that have a status of closed but no close date. And you can see some of the others, negative and 0 durations, has a close date but no status, closed exactly at midnight to the second, etc. So we went through these metrics and developed a standard line and also a P chart for each one of these. So let's take a look at the top 3 here. So this is my poster child, invalid zip codes. Um, and of course, the interesting thing about this is that there's a very reliable source of what the valid zip codes are, and that's a USPS database, U.S. Postal Service database. So this is a look over a 15-year period of the percent of records that have invalid zip codes. And you can see from the y-axis scale, it's a small percent, but it definitely shows some trends, and you can see some variation occurring as we get towards the end. We took this basic data and applied the proper methods to put it into a P chart using R's QCC package. And you get a chart that looks like this. This is kind of why it's my poster child, because this particular metric is almost in control in the statistical, in the SPC world. I'm not too worried about these data points in red below the lower control limit because they're defects. But I am concerned about these ones that are above the upper control limit. And it turns out there's 16. This is measured on a monthly basis. So there's 16 that are above the upper control limit out of 180. And you can clearly identify where those are. And of course, the idea was once you identify what the deviation is, you try to find the source and correct it and find out what happened. Let's take a look at 2 more. One of them is community boards. Community boards are kind of specific to New York City. They're essentially a neighborhood, and it's used as kind of a local governance organization that works with the various borough presidents to try to represent neighborhood interests. And of course, there's a finite set of these, and it's pretty easy, again, to sort of validate the overall data feed against this set. So in this case, we can see that for about the first 10 years, um, there's very few invalid community boards. And then mid 2019, we really see an upward trend here and a much higher. And let's drop this into the control chart world. And again, we can see that for 10 years, they're very far below the lower control limit. And then something happens that pushes us into an extreme position that's way, way, way above 3 standard deviations based upon a previous history. And and obviously that's the idea, identify where the problems are and see what caused that to happen if you can do that. The last one I want to look at is the where we have a service request where the status is closed, but there's no close date. Now, this is important because the difference between the created date and the close date gives us a duration of how long it took a city agency to respond to a particular complaint. And that response time is closely scrutinized in the city of New York for the various agencies. How fast did the city respond to a homeless assistance request? How quickly was an inoperative streetlight repaired? How long did it take to get a sidewalk repair uh, addressed? And when you're missing the close date, that's a problem in terms of computing that. And this is a particularly disturbing trend because it starts out for almost 13 years at basically zero, and then in mid 23 it just goes erratic. And you can see this on the control chart. It's very clearly displayed. It's a well, very desirable outcome, and then something happens that generates a very out of control situation that we should probably look at and see how that came about. So for those 8 metrics, this is kind of the summary. Sort of jump to the end here. It turns out that 6 of those metrics are trending down, albeit with some pretty erratic behavior. And 2 of them are trending upward, one pretty dramatically. Like this is the close but no close date. You can see it went from less than 1% to 8%. That's a really high number to have um, an anomaly where you've closed the record but no close date was captured. And this was the idea to sort of look at how that had trended over time and try to decide if the data is getting better. In this case, we basically have 6 metrics that are getting better and 2 that are not, and we should examine those. Um, so just some final thoughts here. Um, Using the statistical process control approach was helpful and informative. Um, it works best, of course, on systems that are in control as defined by those processes. But it turns out that, making this jump from a quality assurance process that's typically applied in the manufacturing world, where you have parts coming in to make up an assembly, and if you treat the data sets in a similar fashion, you can you can use the associated SPC charts to really identify anomalies and activities that should be looked at. And of course, the idea is that you develop software and maybe AI processes that can help with the actual detection and monitoring of the QA and these spikes in the feeds, and you can present that over time and update it frequently to try to catch those kinds of challenges that come in. But one of the big differences we found between looking at the data from New York City and sort of this weird experience we had at Google, um, at Google wanted the data feeds to be better, and the suppliers wanted their data to be better. They wanted a happy customer. So there was an incentive on both ends to try to really get high quality data sets. That's a challenge when you're in the open data world, because one of the things we saw in New York City was that there really is no czar who's managing or trying to um, incentivize the various agencies to improve their data. So if you want it to get better, you can't just depend upon random activities. You really need a focused effort to improve on data quality. And that has to start really at the originating sources, the New York City agencies like, Department of the, Department for Homeless, Department for the Aging, NYPD, Housing Preservation Development, because that's where the data comes from. And it really brings up this question of who's watching the data from a quality standpoint, who's enforcing data quality issues. Easy to do in manufacturing because the supplier and the manufacturer have an incentive to align their quality initiatives. But we found that pretty challenging to do into the open data world, other than taking presentations like this and making them available to some of the leadership of the New York City open data world, which we have done. So that's kind of the wrap on the presentation. Dr. Yan and I did do an additional paper earlier that's available for public comment and review, and we encourage you to take a look at that. Thanks very much for participating. My email again here and in the chat window. Happy to take some questions in the time we have left. Thank you.
Thank you, David. I'm going to break with the trend so far for GASP, and I'm going to ask you some questions now. Partly because
Okay.
we have we're okay on time, but
Yeah.
also I'm worried about your battery.
So far, so good, I guess.
Well,
I'm
and
on a
also
mobile
my
hotspot.
memory.
If you can, I'm tethered on a mobile hotspot. So this is really like, yeah. Okay.
Seems
Yes,
to
ma'am.
be pretty stable. Um, well, yeah, the other thing that's I can't rely on is my memory, but I did take a couple notes in the chat just to remind me. But Lisa had a question. She said, "Do you think people don't enter the close dates because these are scrutinized and maybe have consequences? And do you have any hypotheses on why these are happening?" That was kind of my question too. Any
Yeah.
idea why these big changes?
Um, we built software for the 311 system when I was in my position with the city. That software doesn't rely upon entering a close date. That software does the right thing. When you set the status to close, it automatically captures the close date.
Oh,
Now, a number of the feeds come in, a number of the agencies, some of the big ones, don't use the 311 native system. They're using their organic systems and they feed the data into the 311 data lake via an interface. So unfortunately, we kind of don't have the insight from those data streams that are dumped into the open data store from other agencies. And regrettably, it's kind of difficult to understand why why the status would be set to close, but there's no close date. I wish I had insight to that, but unfortunately, I really don't. I just know that you would think the right way to develop the software would be that you don't enter the close date. You don't even enter the create date. You just open the record and the create date timestamp is captured. And when you close the record, a date timestamp is captured. But apparently that's not always the case.
that's really good examples of, how should you design software that programs that make it easy on the user and
Right.
maybe perhaps provide metadata uh,
Exactly.
that's helpful. Thank you. Yeah, my other question was, I didn't really, just from quickly looking at it, I didn't see any really major effects from COVID. Did you
Oh,
see anything?
well, I didn't show the overall volume of 311 just for time purposes, but yeah, we tracked that. And as you might imagine, there was a very significant spike in the overall usage during 20 and 21 that was certainly attributed to the COVID pandemic. I'd like to take a little shout out to the team that did performance testing when we implemented the new software for 311. It was 2 years before that. Had we not done that and done lots of performance testing, when the COVID hit and the load nearly doubled almost overnight, the system would not have been able to handle that. So it's again just sort of an example of good software practice. And I will tell you that since COVID, the number of uses, the monthly uses of the 311 system have continued to grow at about a 10% per year rate. So they're getting up to about 3.6 million requests per year now.
Wow.
But that started with the big spike during COVID.
Wow, that's fantastic. Okay, well, thank you so much, David. I really appreciate it. And others, if you have questions, oh, there's two questions here. Let's see. So one question is, do you have any comments about applying continuous integration, like what you mentioned with the Google Maps for open data? Oh, and continuous deployment.
Well, yes, I think we'd like to see something like that put in place. That something would be, yeah, I mean, we would, yes, yes to both of those.
Yeah, like great ideas.
Yeah, great ideas. That's exactly what we would kind of recommend and what we would like to see. And I will say we have had some very close relations with the people in New York City who manage the open data software and the processes and the tools that are used. They're very interested in doing something like that. So we'll keep our fingers crossed.
Fantastic. Well, thank you so much. And if your battery lasts, hopefully you'll
I'll stay
stay with
with you.
us.
Thanks so much.
You're welcome. Thank you so much, David. Okay, our next speaker is Atul Rawal, and I don't know if I'm saying your name right. But you can now, you're sharing your screens. Thank you. And go ahead with your talk.
Okay. I think you said you can see my screen. If you're not, please let me know.
Yeah, I'm having a little hard time hearing you.
Okay.
Am I the only one having a hard time?
Is it better now?
Yes.
Okay, perfect. Okay.
Yes.
Okay, so thank you everyone for being here. Today we're presenting our work on a semi-supervised active learning approach for block status classification for the Census Bureau. The outline of the talk is fairly simple. Gonna quickly go over what the goal of the project was, and then we'll cover the data set that we use for this, followed by how we use machine learning and explainable AI, and then we'll wrap up with some of the challenges that we faced throughout the project and a summary of the project. So the goal for the overall project was to develop a machine learning pipeline to improve both the data labeling and the classification of the parcel data to enable new data-driven insights while reducing cost and effort for data assessment. If you know, every 10 years, the Census Bureau has to do a decennial, and for that, we need to know where every single block is, and we need to label those either passive, undercoverage, or overcoverage. And manually, or previously, this was done manually by using human in front of a computer or going door to door, but we're trying to automate that process a little bit just so we can save some kind of cost and some kind of time. So the main data source for this project is the Census Bureau's ID database, which stands for the Intelligence Database. It is a combination of different data sources from multiple sources, like the master address file, the USPS delivery sequence file, the Tiger file, the different parcel data that we have within the Census Bureau, and another project from the Census Bureau called the Automated Changes section, where we're able to detect whether a change has happened on a specific parcel or not. The data set itself combines all of the blocks within the United States. It has about 8 million, approximately 8 million point something blocks, but within these, only about 40,000 blocks have been labeled so far, which means a little over 8 million are still unlabeled. So we have a very large data set with a very large portion of it unlabeled. And within the data set, the main classification we're looking for is whether a block is passive, undercoverage, or overcoverage. So we're trying to see whether there's a change or no change within the block from the last decennial versus whatever we currently are at. As I mentioned, the data set is either passive, undercoverage, or overcoverage, but we also wanted to see how the machine learning models would react or how they would perform when we kind of combine the two change classes into one. So we combined the overcoverage and undercoverage into a class called active instead of having three different classes. We now combine the two and make it a binary class. And we kind of wanted to see how the performance would be for machine learning models for the binary class models versus the multi-class models. So We first wanted to look at what the data was, check for any potential issues there to make sure that, before we run the data through the machine learning, we have a decent data set and we're not getting really bad results down the line because, one of the great things in machine learning is that garbage in, garbage out. So the better data set you have, the better results and predictions you'll be able to make. As mentioned before, the data set we had 3 different classes. However, there was a very heavy imbalance between the 3 classes. As you can see, the passive class was very, very highly imbalanced, which was a majority, almost 70% of the data set, whereas the overcoverage and undercoverage were less than about 20% each. And even when we combine the undercoverage and overcoverage models, we still have a very large imbalance towards the passive class. To solve this, we wanted to see if we should use undersampling, oversampling, or a combination of both. So we kind of did both and wanted to see which would provide us better results. So with the 3 older multi-class models, we performed both oversampling to kind of even out all the data sets using the synthetic minority oversampling techniques. And then we also performed the same thing for the binary class with the active and passive class, and then once again performance mode to do that. We also performed undersampling using the k-means undersampling models. And then once we had all 3 of the, imbalanced, the the oversampling and the undersampling data set, we then wanted to kind of proceed and go ahead with the machine learning models. So we first tried machine learning with the very smaller 40,000 set of semi or supervised learning with the labeled data set, because we wanted to make sure that machine learning models were at least able to predict correctly and accurately on these labeled data sets before we proceeded to make predictions on the unlabeled data set. So with that, we first tried supervised learning on the unbalanced data set with the passive blocks being the majority. And we saw that, the decent results, not the best. We couldn't get an accuracy of over 77% with an F1 score of 99. But we wanted to make sure we weren't underfitting or overfitting here because we had a very high imbalance between the classes for both the multi and the binary class. So we then performed undersampling using k-means to see how the models perform, and we saw a decline in the performance for the undersampling for all the models for both the binary class and the multi-class. Same with the precision and recall and F1 scores. And then we finally performed oversampling to see how that would perform. And then we saw a slight increase in the accuracy and the F1 scores for both the multi-class and binary class. So we decided to move further with the oversampling models because that gave us kind of the best performance. Even with the models performing fairly well, we kind of wanted to show that, machine learning is great in theory and all, but how do you put this into practice? So we kind of integrated our results from the machine learning models directly into the intelligence dashboard to show that the predictions from the machine learning models can be input directly in here, and then the dashboard itself can show you what a machine learning model is telling you versus what the actual status of the block status was. So here we input the models directly into the dashboard and then highlight what the model's prediction was versus what the actual prediction was, which was labeled manually by a human labeler. Once we had that, we also kind of wanted to look at what features made a direct impact on a block being either passive, undercoverage, or overcoverage. So we utilized Shapley to generate feature relevance scores for all the blocks. We did this for at the global scale and also the local scale and for each different class as well. We took these results for each block and once again imported them and integrated them directly into the dashboard to kind of show, okay, well, if you're clicking on this block, we'll give you what the prediction is, but we'll also show you which features went into directly making this block either passive, undercoverage, or overcoverage. So once we had that, we kind of wanted to move on to the rest of the data set, which was unlabeled. So the rest of the 8 million blocks. And to do that, we couldn't just do supervised learning because we don't have that labeled data set. So we came up with a active semi-supervised learning approach where, for the 8 million blocks we first made predictions we first trained our models using the 40,000 labeled data set, made predictions on those, and then we would validate those predictions using a human labeler, and then add those data, the labeled or the validated data set back into the training data set, and then rerun the model again, and then get another set of training data added back to the training data set, get another validation set added back until we have the full 8 million blocks covered eventually. This kind of approach also ensured that we had a human in the loop though for the entire model process to ensure that the models were predicting accurately and fairly, and there wasn't any kind of bias going on for any of the models or the block statuses themselves. So with the models, we're able to kind of export these predictions directly. And then for each of the models, we can say, okay, well, the logistic regression is saying under coverage, or the gradient boosting is saying over coverage, or one is saying passive, or the other is saying under coverage. For any of the blocks that had more than 2 models disagreeing with the others, we had a human labeler manually go in and check those to see which was the actual accurate result, and then add those results back into the training data set. Similarly to the supervised learning models, we once again imported those data sets and integrated them directly with the intelligence dashboard to kind of highlight which the model's predictions were. So here the blue is under coverage, the green is passive, and red is over coverage. And we can do this for all the 8 million blocks once we have the entire data set run through the models. While this was, a good set and a good approach, one of the challenges with unlabeled data sets is how do you validate your decisions and how do you validate your predictions? Because you don't have that ground truth, you kind of have to come up with different ways to do that. And one of the ways that we kind of thought about was using these predictions, using the known passive blocks that we have a set of that we know are 100% passive, and we don't necessarily have to run the models on them again. So to see how accurate the predictions were, at least for these passive blocks, we kind of combined the labeled blocks with the known passive blocks, and then made predictions on those to see how accurate at least those were. For that, we generated a set of 100,000 blocks with 27,000 to be known passive blocks, and then we ran the models to see how accurately the models are able to predict these 27,000 blocks as passive. And what we found was that out of those 27,000 blocks, 24,000 were predicted accurately, with the rest 13% to be labeled as either under coverage or over coverage. So not the best, but also not the worst. So we got a decent set of validation using the passive blocks, which kind of gave us a little hope that our models were, performing somewhat decently and weren't completely horrible, and we didn't need to start all over again. With that, we're still facing challenges, mainly with the administrative data being messy because we're combining different sources of data from not just within the Census Bureau, but also external sources like the USPS. We kind of have to clean that up a lot. We have different fields, different features. We have to combine those features, make sure that, one data set isn't completely different than the other one. The lack of labeled data set is still a major, major challenge because we still only have less than 1% of the data labeled itself. And then the last one for our semi-supervised active learning approach is the time it's taking to manually validate the predictions we've made using the machine learning models. Even though we're able to kind of speed up the process, it's still taking a lot longer than we would like. So we're trying to figure out a way to kind of speed up that process so that we're not spending a lot more time validating than we're actually making these predictions. So in summary, while manual canvassing and labeling has been great and helpful in the past, it is very cost and time effective. And this is kind of where machine learning can help alleviate some of the burdens, at least for making predictions that can later be validated. So we've shown a proof of concept to use this machine learning pipeline to perform core Census Bureau operational tasks, at least within the decennial for every 10 years. This also kind of has the benefit of removing some of the human bias when you have to go through each block separately. And it also hoping to showcase Census's expertise and evolution in applying some of the machine learning techniques within geographic data. And with that, I'll take any questions. And if you want to get in touch, there's my email address. And we've also published this paper within the Papers in Applied Geography journal, and I believe it's open source. I'm not 100% sure there, or open access.
Thank you so much, Atul. That was very interesting. We're going to just jump to the next speaker though, but I would encourage folks to put questions in the Q&A and we will address those at the end. I have a question for you, but so I hope I don't forget. Anyway, great talk. Thank you. So next up we have Francisco. I was going to try to say his last name, but I realized that I probably couldn't do it justice. So our next speaker is Francisco, and I'll let him introduce himself before he talks about an R Shiny dashboard. So feel free to share your screen and start your presentation.
Can you see my screen?
Yes. Oh, no, I cannot. I'm sorry. What am I saying? No, I can't.
Let me try again. Sorry about that.
Okay, something is there now. Just your screen or your desktop.
Might be reversed.
Oh, okay, your presentation's there, but it is not, oh, there it goes. Yep, perfect.
Okay, great. So thanks, Wendy. I'm Francisco Cifuentes Pierrel. I work at the U.S. Energy Information Administration, which is the statistical agency under the Department of Energy. Today I'll be talking about how we at EIA used an R Shiny dashboard to edit survey data. So the Residential Energy Consumption Survey is a survey conducted by EIA every 4 years. The last results we have are from 2020, and we're currently working on releasing results for the 2024 RECs. And something that's interesting about the RECs is that it actually is a concatenation of 2 surveys. The first part is the Housing Characteristics Survey, and this is the part of the survey that's probability-based sampling. So every household in the US is eligible to be part of the survey. From that, we pick a sample, and then we go out and ask that sample for questions regarding structural information about their house, some basic demographic information, as well as any fuels used and end uses that are in the household. And then the second part is once we have all our respondents, or let me go back for a second. The Housing Characteristics Survey is completely voluntary for any household that's part of our sample. The second part of our survey is the Energy Supplier Survey. And for any household that's a respondent in the Housing Characteristics Survey, we can go out to fuel suppliers. So if you're in the DC area, something like Pepco, and we can ask the energy suppliers, and this part is mandatory for the energy supplier, we can ask them for any billing data related to the household. So then we have a full set of housing characteristics. We know how much energy they're using, and then we can break down the energy use into different end uses that are present in the home, as well as any structural information that might affect how that energy is used. So here's a very oversimplified view of the RECs processing from the raw data until the final public file that we release. For this presentation, I'm going to focus on editing, specifically editing of the household characteristics data. But there are other steps after we do our editing. There is imputation of missing items, there is weighting. We also, like I mentioned previously, we combine it with our ESS data that has its own editing process. And that all gets combined into our final microdata. And for 2024 RECs, we're currently finishing up editing. We're moving on to imputation and weighting, but we still haven't released results. But I will talk about what we did for editing for the 2024 RECs. The 2024, or editing in general for any RECs, not just 2024, consists of 2 main steps. The first is automated editing. Automated editing itself consists of 2 different types of edits. The first is batch edit. These are edits that are essentially, if a certain criteria is met, then we do a fix to the data automatically. So for example, down here, if you tell us that your home was built in the year 1300, we're going to assume that's false and we'll set the year made variable to missing. Another type of edit we have is called derived editing. So we have variables within our data that we don't ask about directly, but from the variables that we do ask about, we can derive another variable. So for example, total rooms is not a variable that we ask about directly in our data, but we do ask you how many bedrooms you have and how many other rooms are in your household. And then we can calculate total rooms from other rooms plus bedrooms. What I'm going to focus on for this presentation is not automated edits, but rather manual edits, or what we within our team call analyst edits. I believe I use the term analyst edits throughout the presentation. So just know that analyst edits and manual edits are synonymous. An example of something that would require manual edit is if a respondent did not provide us with housing type. Housing type is the only variable in our survey that we do not impute. It is a very critical variable. And as such, we could code up a program that could give us a very good guess of what housing type is based on other variables and data that we have. But we prefer, since it is such a critical variable, for someone to go in and actually look up the household address, see what information they can find, and inform themselves that way of and inform themselves and provide the housing type for the household in question. So our motivation for an editing dashboard, we had a lot of files in 2020. Here's an example on the right. Every case that required editing, we would need to run some SAS code that would generate an RTF, and a lot of cases fail edits. So we ended up with many, many RTF files. And where we would log our changes or anything we wanted to modify in the data, that those were across several Excel sheets that quickly got a little bulky, a little unwieldy. And we stuck it out for 2020, but we knew that for 2024, we would want something different. Also, only now we have SharePoint for some of our files, but back in 2020, we did not have SharePoint. And as such, only one person could edit a file at a time. So I got a lot of these questions. If someone wanted to edit the tracking sheet, sometimes I would forget I had it open and they weren't able to access it. So I'm sure a lot of you experience working with the shared drive can lead to these types of issues. And also, it's just a very resource-intensive step. It takes a lot of time to go through these cases, look them up. So any savings we can do time-wise, it's always welcome for analyst editing. So a quick overview. Due to time constraints, I can't do a full demonstration as I would like, but I'll just give an overview of what the dashboard looked like. So it consists of 17 tabs, and each of these tabs was previously a separate Excel file, maybe a separate Word file, a PDF that were spread out across several locations, and now we have them all into one singular dashboard. Another positive of having this dashboard is that we can automate a lot of audit trails whenever you make a change to either, say, the tracking sheet, to any data, to any guidance. We can track who made that change, when it was made, and any notes they might want to provide regarding that change. Down here is an example of what the tracking sheet looks like. Before, in 2020, this would have required an Excel file to be generated and then manually uploaded for everyone to edit. Now, as long as you upload the data file correctly into the dashboard, this file is automatically edited, and then people can come in and through the dashboard, sign out cases, change any data, drop any cases. There are times where we might want to drop a case entirely from the respondent data. For example, some apartment homes especially, they might answer for, it might be a 4-unit household. We sample only 1 unit, but they but they answer for all 4 units. If that's the case, then we're going to want to drop the household from our final sample. Here, any notes that are provided, and lastly, whether the case, maybe it's not a quite easy case to fix, so you want to talk with others on the team about how to discuss it, you can always flag the case for discussion. Here is the editor and data viewer tab. This is where most of the editing actually happens inside our dashboard. I'll go through it. So here on the left, you would go into the dashboard, go to the tab, you would select your name, and then that would load up every case you have either edited or have still to edit. So either any edited or unedited cases. Down here, there's inputs you can put in for which case IDs you want to show, either all edited or unedited cases again, and then within unedited, there's different categories, either cases you've flagged for discussion or cases you have not flagged for discussion. Then here you can select your case ID, and then it is not shown on the screenshot due to spacing, but under this screen, if you were able to scroll, you would be able to see the code book with the responses, both the raw values and current values for the case ID. And then you can also break down that code book by section. We had a section for every edit that was helpful variables that we thought would be relevant for the specific edit failed. So that's this section here, that was the default view, but you could also just pull up the entire code book or any other section within the survey. As for editing the case, we would show information related to the address of the household, what the actual edited failed, and a description of it. In this case failed for missing housing type. And then you could select using these radio buttons what you wanted to do with the case, how to resolve it. Your first option, do nothing, get back to it later. You could flag it for discussion. You can make no changes and finalize. So this means you looked at the case, you decided everything was okay, you decide to make no changes. Or you can edit the variable or decide to set a variable to missing. And lastly, like I mentioned previously, you could decide to drop a case entirely from the file. So to edit a case, in this example, we are editing type HUQ, which is the housing type variable. This is a select input here. So you would click on it, would pull up different variables that you can edit. You would select type HUQ, then you can add it to this table down here. If you accidentally select the wrong variable, you can always just remove it from the editing table. And then once you add the variable, it'll pull up information for that case ID. So in this case, after you select type HUQ, it'll load in the current value. In this case, it's just missing. It'll give you that description telling you it's missing in blank. And originally this cell here for new value would be blank, but you can double click it. You can enter a value. In this case, I entered 5, which means an apartment in a building with 5 or more units. You can enter any notes here as well. And then if you do want to still discuss anything about the case, you can submit your changes. But if you click here, it'll also flag it for discussion. So it won't be fully closed, but the changes will still go through. And you can submit the case by clicking here on the bottom left where it says confirm and resolve case. And after you click on that confirm button, you'll get one of these views down here. It'll either tell you, hey, the data went through, no problem. Here's a summary of what you did, or it'll give you a warning or an error. And this is very helpful to have because human error is inevitable. People might type in the wrong number, they might select the wrong variable and not notice it. So having this built-in QC process, not having to wait until all the changes were made and then reviewing the changes, this made it very helpful for us to be able to lessen the QC that we needed to do of the changes that we were making. Also using RShiny, we were able to create backup files for the changes log and the tracking sheet. These updated every 24 hours automatically. Any editing progress files before someone would need to go into SAS every week and run and see how much progress we were making. Now this was you could either view it at any time within the dashboard, and it would also just create a log of your progress every week. So we thought this was very helpful. Multiple people could edit cases at the same time. So a lot of the issues we were having in 2020, we were able to resolve. Quick comparison with 2020, I will make the note that Rex is not a time series, so every survey is different. It's a little complicated to compare across surveys. We have new questions that are released, new editing specs. But with all that being said, we did have less cases in 2024, which led to less cases requiring editing, but we did finish up analyst editing much earlier, both for 2024 and 2020. We started right around early January. So we saved about 2 months, and it's not a quantitative measure, but just speaking with my coworkers, we really enjoyed using the dashboard. We would estimate that it was every case on average took about half as much less editing time than it had taken in 2020. We never had a backlog of cases that we needed to edit, which did happen sometimes in 2020. We were able to focus on other projects while still editing cases. I'll hurry up a little bit. There were some drawbacks. The initial setup, everyone needed to have R and RStudio installed, and just making sure, because we did have some people on our team who had never used it, just making sure everyone had it installed correctly, had all the packages loaded in. That required a little bit of management. One thing, we had the Google Maps API built into the dashboard. If you go on the website, let's say your sampled household is number 100. If you go on the website and look at Street View, it'll always point in that direction. If you use the API, the free embed API, it's not guaranteed necessarily that Street View will point in that household. So it can be a little confusing at times. And so if we ever wanted to view the house on Google Maps, I found it much easier to just go on the website for that reason. And some future improvements we might want to make, because of the initial setup and everyone needing to use R and RStudio, we thought it might be easier just post this on some kind of intranet and then everyone go to that URL rather than needing to run it directly on their laptop. We do plan on using a similar dashboard for ESS editing. So just a reminder, ESS was that second part of the Rex of our survey. So we will use it. Another idea, live QC check. So right now we only QC any changes that are made after someone presses submit. What would be nice is as they're editing the data, they could get a live pop up in that mode or some kind of notification saying, hey, if you submit, this is going to lead to an error, rather than once you submit, here's the errors. And then I found this package after, but our hands-on table, it allows for numerous types of inputs directly within data tables, as you can see here in the bottom right. And you can drag and drop a lot easier. It's very similar to how Excel works. And so we thought it would just be a lot nicer if we were able to transition a lot of it into this package here. It works very nicely. It's a lot more user-friendly if you've never used RShiny. And with that, here's my contact information if there's any questions that I can answer.
Perfect timing. Thank you. Okay, I told we're going to come back to you because what Francisco just talked about is fresh in everybody's mind, at least my mind. So I think there's one question right now for Francisco. Do you return to the same instrument after the incorporation of administrative data for analysis updates?
So I'm not sure what's meant by the same instrument.
You could think about it and type oh, somebody's raising their hand. All right, and I'm gonna have to figure this out. I think I have to go here. Sorry, this is Megan, I think. Okay, okay, go ahead, Megan.
Yeah, so I submitted the question and I was curious because on your workflow, I saw that your administrative data, so like your example from Pepco or wherever, comes in after this editing phase, if data were to be received that during your analysis doesn't make sense with the respondent data, do you go back to this R space to make those updates or make changes, including to the administrative data, or do you use a completely different tool?
Yep, so that's a really good question. So we do have a separate editing process just for the ESS data. And one of those processes we call reconciliation, where we will look at your bills and look at your housing data. And if we find anything that don't match, a common example is you reported electric space heating, but there's no spike in the winter for electricity, but we do see a spike in your natural gas bills. If that's the case, then we have a process where we'll edit the household data to better reflect the information that's contained in your billing data.
Okay, so with that edit is still done in this initial space that you're talking about today, correct?
So yeah, but we would do that within the ESS editing, which is it's a very similar process, but we just do it at a later stage once we have that billing data in.
Thanks.
All right, thank you. Others put your question. Oh, somebody just put a question there. If two users are updating the same housing unit record, does the app flag it later, or does it create a conflict? This question is for San Francisco. Okay, cool. Figured that. All right, thank you. Did you get the question, Francisco?
Yeah, I heard. So the way it worked was you would first have to sign out a case. So once you signed out a case, it was impossible to have two people edit the same case, because once you selected your name, only your cases would come up. It is possible that you would have two people trying to sign out the same case, at the same click of a button. And even though it'd be very unlikely that they click at the exact same time, I did have a built-in method where it would prioritize one of the two. So then one person would get a pop-up saying, oh, you've signed out, such and such case. And then the other case would get, oh, I was not able to sign out this case, try again. And then when they try again, it would refresh the data table and they would no longer be able to sign out that case.
The dashboard's really looks very extensive and with like lots of error checking and things, and it just is what you just talked about. And of course it was designed for your application. But so maybe it doesn't make sense to, share code or something, or maybe you can't share code, but do you have any articles or papers or descriptions of, how you did it, or any code that you could share? Because I think it seems like you have a lot of great programming ideas in the app.
And so we don't have any papers or anything we've published relating to it. In fact, this is the first time we've kind of talked about it outside EIA.
Well, Lisa's going to talk about the Journal of Data Science special issue, so for GASP, so there's an opportunity there for you, because it does seem like, as I said, that there's perhaps some good design ideas to share.
Yeah, I mean, if anyone would like to talk more about it, we could probably show a lot more about it outside of the presentation.
Ooh, maybe I should have you give your own seminar at our Govies or something.
Yeah, I'd be more than happy to.
I'm gonna make a note of that. Okay, so there were a couple questions for Atul in the chat, and okay, I gotta see if I can find them. Because they weren't shared with everybody, so I'm just gonna read them. So David asked, Atul, is his work akin to the classic data science clustering approach, or would that be the next step? And I'll just read Atul's answer, and then he could expand if he wants. He said, yes, we took the clustering approach first with PCA to do a completely unsupervised learning model, but we're not able to get the performance to be on par with what we wanted. So then we pivoted to the semi-supervised approach. So Atul, if you want to expand on that, just
Yeah.
chime
So
in.
yeah, because we had such a small set of label data set, we kind of tried going head on with the unsupervised learning first. But we weren't really able to kind of really pick out the actual clusters that were given us, the passive or the undercoverage or overcoverage. They were clustering on a different set of information, which kind of was necessary, but not what we were looking for. And the model performances really weren't at par either. So we kind of just said, okay, let's just try and see how semi-supervised works at least.
Yeah, I really liked how you tried different approaches and assess them. Which kind of going back to Francisco, I'm sorry, what I forgot to also say, I think I forgot this, was I really liked how he assessed the results, like showing, oh, this is like the return on investment, if you would, on creating this app, that it did save 2 months of time, labor in doing the editing. Yes, granted, it wasn't like there were fewer cases and things, but I still think you made a case for that, that it was definitely worth, having a tool like that. So I think going back, always looking at, what you did, of course, we should do that, is important. And then my question to Atul was, where's my question? Oh yeah. What is one of the classes more important than the others? And if so, which one?
Yeah, we really kind of wanted to focus mainly on the passive class because about 75 to 80% of the blocks within the US kind of remain unchanged throughout the 10 years. It's the 15% that does change somewhat every now and then. So we at least kind of wanted to get those passive blocks accurately predicted. That way, when we're validating the model predictions coming from these machine learning models, we're not focusing a lot of time on the blocks that we know are passive, and we can only actually focus on the blocks that we know have some kind of change. Because those are the blocks that really kind of give us a little bit of information on how the US is shifting, how the geographic locations are changing from, 10 years ago to now versus the next 10 years.
Yeah, thanks. Was the and I forget what the imbalance was in the classes, but would it make any sense to, or do you think, yeah, I guess it would make any sense to try to change it to a 2-class case, like passive or not passive?
Yeah, we tried that. We tried so multi-class and active, and so we tried multi-class with passive undercoverage and overcoverage, and then we combined the minority classes into one of an active class. And what we saw was we didn't really see too much of a difference between the multi-class versus binary class. And then we just kind of stuck with the multi-class because eventually, with the active class, manual labeler would have to go in and check what kind of active coverage it was, whether it was undercoverage or overcoverage. So we figured let's just save some time downstream and then just stay with the multi-class since the difference wasn't as significant as we kind of were hoping.
Perfect. Okay, great. Thank you. And I think that was all the questions. Lisa, did you see any more in the chat that maybe I missed?
I don't think so. We did put a link to Atol's paper in the chat for everybody. And then the other thing too is I've been capturing whatever links we put into the chat so we can share those later with people as well. So I think that's it. Did we have a couple minutes if the panelists have questions for each other.
Good point. I see David's battery lasted. That's good. Okay, well, I don't see any more questions in the chat and I don't see any more questions in the Q&A. So thank you again to all the speakers. It was a very interesting session and people stayed. So that's always a good indication that, what you're what you're talking about is interesting and motivational. So I was happy to see that the numbers stayed high. Okay, so Lisa, I guess you want to do the closing remarks,
Sure
And
thing, Wendy. Yeah, I'll just put a quick slide up on the screen, at least in theory.
your camera's off. I don't know if you wanted it on.
Yeah, I guess I could put it on.
There you are.
So yeah, this way it's just not this sort of disembodied voice from beyond on the internet. So just a few quick announcements, presenters. Thanks for another great day. This has been really fantastic, and tomorrow and the next day are going to be great too. So I'm really excited. Um, all of the presenters, you're going to get an email from us next week with information about slide sharing and an opportunity to sort of, submit an updated deck or something like that in case there's something, that you need to remove or change or add or what have you. You'll also get some information about the JDS special issue that we mentioned yesterday in the opening for the conference. So look forward to that with some instructions about how we're going to be running that. Tomorrow we have a Quarto workshop with Isabella Velasquez. That's going to start right at 10:30. You should have gotten a separate link from ASA from Donna Lalonde to be able to access that workshop. So please, check your email for that. At 12, we come back to the regular conference sessions and use the same link that you've been using for the past 2 days to access the conference sessions. And then I guess that's pretty much it for today. Thank you all very much. Greatly appreciate all the efforts of the presenters, all of the chairs, session chairs. It's been a really exciting day. So thank you and have a good evening.
Great. Thanks, Lisa.
So I think we're set. We can just
I was trying
close
to
it.
figure out how to save the chat.
I did.
Yeah.
There's
Yeah,
three dots at the bottom.
there's also a little thing that looks like a page there. And I think if you click on that, it will save the chat. I've been during the day, if like people put links or things like that, I've got like a master list of links going. Let's see. So I've got here, I'll show you what my screen looks like so that you guys can see
Alright,
what
so
I'm
I'm gonna
doing
save
here.
the chat, show in the folder.
Yeah, I
Okay,
think,
I
yeah,
just saved the chat. Thanks to people.
okay, you got it. Okay.
Yeah.
So,
I'm gonna rename GASP Day 2. Alright. What? Can't be completed because it's open. Okay, whatever. I guess I have to get out of Zoom. Okay, I'm sorry. I'm waffling.
no problem. No problem. So, yeah, so tomorrow morning, I still wasn't seeing the link for the workshop for the morning. So Peter, you're going to be there for sure.